Now coming to special cases of oblique projectile. Okay, here we are going to study two different cases. One is projecting a body up the inclined plane. Second is down the inclined plane. Okay, let us start with the first case. So consider an inclined plane. Assume that this is an inclination whose angle of inclination I have taken it as theta. From the bottom of the inclined plane, we are going to project a body with a speed u, making an angle alpha with inclined plane. Now first what we have to do is consider your new coordinate axis. Along the inclined plane, I will call this axis as x dash. Okay, we are projecting the new axis as x dash. Perpendicular to this is a y dash axis. Okay, so this will be your x and y axis. So I have considered a new axis along the inclined plane as x dash, perpendicular to that as y dash. Now split this velocity u into two components along x dash axis and along y dash axis. So I will write this value u along y dash. See, since this angle is theta, what is u along x dash equal to? U cos alpha. This is u sin alpha. Similarly, acceleration due to gravity. Small g also we are going to resolve it into components. See, if g acts in vertically downward direction, we know down the inclined plane we get g sin theta. Perpendicular to inclined plane, it will be g cos theta. Okay, along downward direction we have g sin theta. So if this is your x dash axis, u cos theta is acting along x dash axis, whereas acceleration is in opposite direction. So what should be acceleration? Ax dash equal to, I again repeat, ux is acting along x dash, u cos theta is acting along x dash axis. Since g sin theta is directed towards origin, Ax dash, acceleration along x dash direction, would be minus g sin theta, since it's acting opposite to x dash axis. Similarly, come to this direction. Along y dash axis, initial speed is u sin alpha. But what is the direction of g cos theta? Is it in the direction of y dash or opposite to it? Since it is opposite, acceleration along y dash axis, I will write it as u cos theta. See, did we get our required four conditions? Ux and ax dash along the x dash axis, u and y along y dash axis. Now this particle, whatever you have projected, will take a parabolic path and come and hit the inclined plane. So let us start from A. It is taking this parabolic path, coming and hitting the inclined plane at a point B, and this point which is vertically downward, I will call this as equal to C. Now after t seconds, if you want to locate its position, okay, I will call this position as x dash comma y dash. How to find out the position of the particle after t seconds? So we know x dash is equal to uxt plus half ax dash into t squared. We know the values of ux dash and ax dash, okay, written in white color. Find out what is its x dash component. U cos alpha minus half g sin theta into t squared. Similarly, if you find y dash, taking by and ay, you will get this relation u sin alpha t, I forgot t here, minus half g cos theta into t squared. See, did we get the position of the particle? X dash as well as y dash. And now if you want to find the time of flight, okay, how do we define the time of flight? Time taken by this projectile to reach the inclined plane. See, during this time of flight, this is y dash distance. Is y dash first increasing, then decreasing, finally becoming 0? So put y dash equal to 0. Small t becomes equal to capital T, which is time of flight. So substitute these two conditions in the above equation. What will you get? 0 equal to u sine alpha t, u sine alpha capital T minus half g cos theta t squared. Okay, when you find out the time of flight, what is the time of flight of this oblique projectile projected up the inclined plane? 2u sine alpha by g cos theta. Okay, solve this relation. You will get the time of flight as 2u sine alpha divided by g cos theta, where theta is the angle of the inclined plane, alpha is the angle at which you have projected the body. And once you know the time of flight, now you can find the range. But while calculating the range, there are two questions for asking you the range. They may ask you range along the inclined plane, that is AB, or range along the horizontal. Okay, if I drop a perpendicular from here, AC gives you the range along horizontal, range in horizontal direction. And AB gives you the range on inclined plane. Okay, so read the question carefully, whether the question is to find out range on inclined plane or range along the horizontal. It's very easy to find the range on horizontal side or along the horizontal, that is the distance AC. Let's see how to find AC. If your velocity of projection is u, see we have projected the body with a speed u, making this angle as theta. Now what is the angle it makes with AC? If this is u, the total angle made with AC is alpha plus theta. So what is the component of velocity along AC, along x-axis? Can I write it as u cos theta plus alpha? I repeat, this is your projectile with horizontal. It is making an angle theta plus alpha. So the component of velocity along AC is u cos theta plus alpha. So if you know the component of velocity, look at the range. Range AC along the horizontal is velocity along the horizontal u cos theta plus alpha into time of flight. See, already we know what is the time of flight. Substitute that. We get the range along AC as u cos theta plus alpha into time of flight is 2u, I'll make it 2u square, divided by g cos theta into sine alpha. Okay, I have substituted the value of t as 2u sine alpha, 2u sine alpha by g cos theta. So this formula gives me the range of the oblique projectile projected up on an inclined plane. If you know this range AC, now you can find this distance AB easily. Let's see how to find AB, that is range on inclined plane. To get the range on inclined plane, observe the triangle ABC. See, in this triangle ABC, which theta relates AC and AB? See, can I write cos theta as AC divided by AB? Since cos theta is equal to AC by AB. Tell me what will be the distance AB equal to? Range AB is equal to AC divided by cos theta. See, already we have got this range on the horizontal as AC. Put the value. What should be your range? RAB equals to, substitute the values, 2u square cos of theta plus alpha into sine alpha divided by cos theta. Again you have g cos theta. It becomes g cos square theta This is giving me range along the inclined plane, and this is range along the horizontal. Again I'm repeating, read the question carefully, whether the question is to find the range along horizontal or range on inclined plane. So these are the terms that you need to remember, okay, when you study an oblique projectile up an inclined plane. Now the second case of an oblique projectile, it is projected or a body projected down the inclined plane. Okay, just now we have seen the equations when the body is projected up the incline. Now opposite, from the top of the inclined plane we are going to project the body downward on an inclined plane. Now this time consider this as an inclined plane whose inclination we took it as theta. From the top of the inclined plane we are going to project a body with a speed u, making an angle alpha with inclined plane. Okay, if I draw a horizontal line, if this angle is theta, this will also be theta. I'll change the color. The down angle, this is theta, and the total angle of projection with the inclined plane, we have taken it as alpha. I repeat, on an inclined plane whose inclination is theta, we are projecting a body with a speed u, making an angle alpha with the inclined plane. Now again project your new axis. I'll consider this as my x dash axis perpendicular to this. This will be your y dash axis. Split u into components along x dash. U x dash is u cos alpha, u y dash is u sin alpha. We have resolved the initial velocity into components. Similarly, resolve g also into components. If this is the direction of g, what is the component down the inclined plane? This is theta. G sin theta. Here you have g cos theta. Now this time you look at it, g sin theta is acting in x dash direction. So what should be the acceleration along x dash axis equal to? Since it is in the direction, I'll take it as positive sign. It is g sin theta. See, we have got ux dash and ax dash. Now come to y dash axis. y dash is acting upward, but g cos theta is acting downward. So acceleration in y dash direction, this is upward and this is parallel and downward, is minus g cos alpha. See, we have got ux dash and ax dash, uy dash and ay dash. Now find out the location of the particle. Again it takes a parabolic path, comes and hits the inclined plane. Let this be A, B, drop a perpendicular. I'll call this as C. Now this is the path followed by the particle along x dash. So find out what is its location. X dash equal to uxt minus half gt square, plus half gt square. So substitute these two values. You get u cos alpha t plus half g sin theta into t square. Now y dash is u sin alpha t minus half g cos theta, this is theta, into t square. So did we get x dash and y dash? Then how to get the time of flight? During the time of flight, y dash is becoming 0. Put y dash as 0, small t becomes capital T. Then what is your time of flight? Substituting y dash as 0, small t becomes equal to capital T, implies time of flight. Okay, and directly writing, you can solve and check out. You get the time of flight 2u sin alpha by g cos theta. Answer is same as the time of flight of a body projected up the inclined plane at an angle alpha with inclined plane. So time of flight remains the same if you project with the same angle. Now coming to range. Again we need to calculate two formulas for range. Range along the inclined plane, range along the horizontal. See, I have given this dotted line. What is the angle made by your u vector with the dotted line? See, this total angle is alpha, this angle is theta. Can I write the remaining angle as alpha minus theta? So what is the velocity along BC? Because we need to find the range along BC. It is u cos, velocity along this direction, that is u cos alpha minus theta into time of flight. If you remember, for up the inclined plane we have got a plus sign here. For down the inclined plane it is minus sign. Then the range BC is equal to u cos alpha minus theta. Substitute the time of flight. Say this is your time of flight. 2u square sine alpha divided by g cos theta. So this term will give you the range along horizontal line. But if you want the range AB, now from this triangle, what is cos theta equal to? Okay, I am calculating the range A to B, range along the inclined plane. What is cos theta from triangle ABC? Cos theta is BC by AB. Therefore, what will AB be equal to? BC by cos theta. We already know the value of BC. Divide with cos theta. Range along the inclined plane is 2u square cos alpha minus theta into sine alpha by g cos square theta. This will give you the range along the inclined plane. And sometimes they may ask you what is its velocity after t seconds. So it's just like an oblique projectile. Vx dash is ux dash plus ax dash into t. Find out what will be its velocity along x dash axis after t seconds. Ux dash, that is u cos alpha minus or plus, it is plus for this, g sin theta into t. Similarly, vy dash, velocity, vertical component of velocity, both are variables this time. Make use of these two terms. You will get u sin alpha minus g cos theta into t. So this is vx dash and vy dash. So these are some of the formulas, okay, regarding a motion of a body or projectile motion down the inclined plane. So these are the two special cases of projectile motion up and down the inclined plane. Okay, basically they may ask you to calculate time of flight or the range for NEET.